Alright, hello math fans. Today we're actually going to cover something, we're going to really combine two things that we've learned. And today's topic is called Systems of Inequalities. Okay, so let's talk about the words here. Systems got two equations or more. Well, in Algebra 1, we're only covering two equations. We'll cover more later, but two equations, which we're used to. Okay? And actually, we're going to be using the graphing method. That's the only way to solve these types of problems. And the graphing method is, you know where two lines, you have to figure out where they intersect. Okay? So we've done that before. And then, of course, we have graphing inequalities, which we've done already too. And remember, when you graph an inequality, there's dotted lines involved and solid lines, depending on if it's a greater than or equal to, or less than or equal to. And then, of course, there's shading involved. So we're going to combine all that. We're going to combine shading and graphing two different lines, and that's what basically systems of inequalities is. So let's just start out with a regular problem here. If I give you guys y is less than 2x plus 1 and y is greater than or equal to negative 1/3 x minus 2. Well, basically what you're going to do, these are already solved for y, so you're going to graph them. And I graph the first one. Now I don't have to worry about so much where they intersect. That's not actually my concern. If it's an equal to sign, then you have to be concerned about making sure you get the exact intersection point. So I'm just going to I really just need to plot 2 points for each one of these. Okay, as opposed to the first ones we did, where I asked you guys to plot just as many points as you can to figure out where it's going to intersect. That's not as important. So let's plot, here we got a 1 here, and then it's up 2 and over 1, up 2 and over 1. And notice it's a less than sign, so it's not an equal to there. So this is going to be a dotted line. Okay. And before we do any shading, I'm actually going to graph the other line, because otherwise it gets kind of complicated on here. But well, we can remember which one's which, especially because this next one is a solid line. So we have y-intercept is negative 2, and it's negative 1/3 x minus 2. So it's down 1 over 3. And this is a solid line. Okay, so now this is the deal. We need to shade each one of these just like we did before. So remember, when it's less than, so let's look at the first one here. If it's less than, we're going to shade below. So this is, our first equation was this dotted line, so we're going to shade below that line. Okay, the next one is y is greater than or equal to 1/3 x. So with this dotted line, we're going to shade above it, because it's greater than or equal to. And what you want to do is you want to see where the shading overlaps. So where shading overlaps, that is our solution. Okay, so what you need to do is you either shade it in darker or use another pen or something. Okay, but our solution is, and I'm going to just shade it in here, and it keeps going. Just because I shaded this one area, it actually keeps going out, and I mean it's huge, the area, it's infinite. Okay, but somehow you need to do that, and I require you guys, you need to write the word solution and put an arrow or something to identify the solution. But you have to write the word solution or SOL or something to tell me that's the solution, and we're done with the problem. That's it. That's all you do. So you graph two lines, you shade, and you tell me where the shading overlaps, and that's the solution of the problem. It's pretty easy. Okay. So let's just try another one here. Now the only thing you kind of need to remember is you got to be careful when you multiply or divide by a negative number. That always gets people with doing these problems, because otherwise they're pretty easy, but you just have to remember when you divide or multiply by a negative, especially obviously when we're solving for y, that's when you need to switch that inequality sign. So let's start with a nice little friendly problem here. 2x minus 3y is less than 12. And the other equation is negative x minus y is less than or equal to 3. Okay, so let's do the first one here. We're going to subtract 2x. And we get negative 3y is less than negative 2x plus 12. Divide everything by negative 3. So y is, and then remember, we just divided right here. Do not forget that step. We divided by a negative number. So you have to switch around the inequality sign. That is so huge. You cannot get the problem correct unless you follow that rule. It's just wrong. You'll shade the wrong area and the whole problem's wrong. So y is greater than positive 2/3 x minus 4. So this is our first equation. And let's do the other equation. So we're going to add x to both sides. So you get negative y is less than or equal to x plus 3. Divide by negative 1. Okay, so again we divided by a negative. So y is greater than or equal to negative x minus 3. Okay, and that's your other equation we're going to graph. Okay, so it's really simple now. Just make a quick sketch here. First one, y-intercept is negative 4. And it's up 2 over 3. It's a dotted line. Okay, and then the next one is y is greater than negative x minus 3. So here it is. Negative 3, and it's a negative x, so it's negative 1 over positive 1, so it's down 1 over 1. You can do another one here too if you want. Up 1 to the left 1, and that's a solid line. Okay, and then we just figure out where we're going to shade. For the first one, it's greater than, and again, you're looking at your final answer. It's greater than y is greater than 2/3 x minus 4. So for that one, we're going to shade above it. Okay, and then for the next one, that is also greater than. So this one you're going to shade above that one too, and above is here. And you can see this. It's basically in this area right here. From here out and here out. All right, all this area, that is your solution. I mean, obviously it keeps going here too. It's wherever they start to overlap, and overlaps everywhere. Here, 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 right. I don't care how you shade it in, okay, but make sure you somehow identify it. You can circle it if you want. That's just one way of doing it. You can put a kind of an area around here and circle it and write solution. But you got to write the word solution, so I know that you know it's the solution area. And this is the reason we know this is a solution. Let's pick a point here, just randomly. If I pick a point 0, 0, which is just right in the middle here, you kind of hidden there. If I pick a point 0, 0, it should work in both equations. Okay, and let's even go back to the original problem. If I plug a 0, 0 into this first equation, it's 0 times 2 is 0 minus 3 times 0 is 0. So is 0 less than 12? Well, yeah, sure it is. How about this one? If I plug a 0 into here and a 0 into here, Is 0 less than or equal to 3? Yeah, sure it is. Okay, so both those are true. Of course, it better be true because that's where we shaded. If you pick a point outside of that, and let's pick a point, I don't know, we could pick any point here. If I picked some point below this, so 1, 2, 3, 4, 5. So I picked 0, negative 5. Okay? And if I plug that into the top equation, I get 2 times 0 is 0. Negative 3 times negative 5 is 15. Is 15 less than 12? Nope. It better not be, because we didn't shade that area. Same thing with the other equation. If I put a 0 in for x, and I get negative of a negative 5 is positive 5. Is 5 less than or equal to 3? Well, of course it's not. So it's no for both of these. That's why that area is false. Okay. Now, if I picked a point over in this spot here, it would be true for the second equation, but not for the first equation. And same thing if I picked a point over here, it would be true for the first equation, but not the second equation. So the area that I wrote solution, that's where it's true for both. All right. Okay, so let's do a couple more here, but that's pretty much what it is. You just graph. You graph 2 lines and you shade, and wherever the shading overlaps, that's your answer. Okay, so let's try this one. Y is greater than 2x, and x is less than or equal to negative 3. Well, these are already solved. So if I graph this, remember, 2x, this with the y-intercept is 0. Don't get confused by that. And then it's up 2 over 1. It's a dotted line. And then x is less than or equal to negative 3. Remember, guys, this guy right here, as we already talked, this is a BAM problem. It's like an x equals negative 3, except we got some shading involved here. So if you remember, x equals negative 3, it's a vertical line at negative 3. So we go negative 1, 2, 3, and we draw a vertical line. And it is a solid line because it's less than or equal to. Oops, it's a little messy here. Okay, and now we need to shade. Well, the first one, you shade above. It's greater than, so we're going to shade above. And the next one is, so here we're going to actually have to extend this a little bit more here. The next one is a vertical line, and you have to shade its x is less than or equal to negative 3. Now, obviously, if you remember, there's no above or below a vertical line, but just think logically. If it's less than negative 3, you're going to shade to the left of it because it's less than it. So if I shade to the left of this line, okay, well, you can see where the shading occurs in this, where it overlaps. It basically, and this is what you can do also. You don't need to just darken everything in, though some people like to darken everything in, but you can see this is where this line is. So here's my solution. This is where everything overlaps. Right? Because it starts to overlap where this line is right over here. And of course, it starts to overlap where this line is right here. So you are going to write solution. And that's your answer to that problem. Okay, and again, if I pick a point on there, any point that I pick on there, it will work in both equations. Okay, so let's try another one here. Y is greater than 2x plus 3, and y is less than 2x plus 5. Okay, so let's graph this. So 3, and it's up 2 over 1. So it's a dotted line. and this one's up to 5, and it's the same thing, up 2 over 1. Well. You guys, I'm sure some of you have recognized this already. These are parallel lines. And you guys should recognize that right away anyway, because it's got the same slope. So they're parallel lines. Well, okay, so for the first equation, the 3, you shade above it. So I'm just going to switch colors here just so it makes it a little bit easier. So for the 3, you shade above, and for the 5, y-intercept, you shade below. So if you look at it, as opposed to making it really messy, I'm shading above for this one, for this line, the lower line, and I'm shading below the line for this one. And remember, it's where it overlaps. So really the overlap is in between here. Okay, that's the solution to that one. So that's kind of an interesting problem. These are parallel lines. Let's just look at what happens if I actually just kind of change this a little bit, and same problem, except I'm going to switch around the inequalities. So y is less than 2x plus 3, and y is greater than 2x plus 5. So if I graph it, 1, 2, 3, so same thing. Up 2 and over 1. So this is a dotted line. Okay, again, these are all parallel lines. Just want to, you recognize that. And the next one is 5 and up 2 over 1. So same deal. But for the first equation with the 3, it's less than. So I actually shade over here. And then for the 5 y-intercept, I shade above it. Where does the shading intersect? They don't intersect at all. So the answer to this problem is no solution. Okay, but you got to be careful. And the only way it's no solution is if they're parallel lines and they're on the opposite sides of the parallel lines. Okay, if I can just talk about this real quickly. I'm not even going to come up with an equation, but let's say your two lines look like this, and this one you shade above the line, and this one you shade above the line. Well, where's the intersection? The intersection is going to be where they start to intersect. So really from this point, this area here, that's my solution. Okay, not below there, but above that. Okay, and same thing if it was, going down, right? If I have two lines and this one is shade, this one's shade below, and this one is, the upper line is shade below. Okay, so the intersection is going to be basically where the shading is. And obviously it keeps going too. It doesn't just end there. Here's your shading is just, it's a huge area. It's infinite area that you're shading. Okay, so that is basically what systems of inequalities is. Now be careful when you guys are graphing, when you're taking a quiz and test and you're graphing, because this is the last thing we've learned. And if I give you guys a problem that looks like this, y equals 2x plus 3 and y equals negative 1/2 x minus 1, there is no shading here. That is huge. There's no shading. This is the one where you actually have to, you plot your points, and you will get, you'll plot a bunch of points here, and you'll plot a bunch of points here, and you'll find that intersection point just by plotting points. This is not this equation here. And then you say, oh, okay, my solution is 2 comma 3. And you'll notice that if I give you a problem that has inequalities, there's no answer blank. Okay, none of those problems did I actually come up with the coordinate. Okay, there's no answer blank, as opposed to these kind of problems, there is an answer blank. You're telling me, hey, where's the solution? Okay, so just be careful about that when you're doing these kind of problems. Look for the inequality. If there's no inequality, there's no shading, and there's one answer. If there's an inequality, then there's shading, and you have to write the word solution in there, and you come up with an answer. Okay? All right, math fans, that's it. Have a good day. Bye-bye.